Hey guys, welcome to Unit 12, Lesson 5. This is our last lesson for the unit. Our topic today is converting rectangular and polar equations. Very similar to when we converted rectangular and polar coordinates. So pause the video and try the warm-up please. The warm-up says convert the following point or into polar coordinates and then identify two other representations of the point. So first of all, this is your rectangular point, which means this is your x coordinate and this is your y coordinate, right? I want to convert it into r comma theta. So what is r? The formula to find r was square root of x square plus y square, and theta was tan inverse of y over x, right? These were our two formulas, so let's substitute them in. So r would be what? Negative 4 square plus 4 square. Negative 4 square is also 16, 4 square is also 16, so r is equal to 16 plus 16, which is rad 32. You can simplify it, or which would be 16 times 2, so it will be 4 rad 2, or this, either or is fine. You don't have to have your radical simplified, that's fine with me. So now, so we already know my r. I'm just going to write rad 32. And now I want to find theta. So theta is what? Tan inverse of y is 4 over negative 4, right? Remember, 4 divided by negative 4 is just negative 1, meaning the negative tells me I'm going to be in a quadrant which where tangent is not positive. So I'm going to be either in the second quadrant or the fourth quadrant. If you look at your points, negative 4, 4, it is in the second quadrant. So I'm going to be in the actually second quadrant. My point is in the second quadrant. So if you were to put this in the calculator, you will just put in tangent inverse of 1. And if you remember your exact value chart, tangent, the value for tangent for what theta is tangent 1 is 45, which is pi over 4. So if I had a reference angle of pi over 4, which would be what? Which would be the exact angle would be 3 pi over 4. So your theta would be 3 pi over 4. So that's how you could have determined it, or just put it in the calculator. It would have given you a reference angle of 45. So let's do this together. Just want to erase this. It looked a little messy. So I know my theta, my theta is gonna be, if I put this in the calculator, I will get 45. This is your reference angle, okay? And now, so the reference angle of 45 gives me an actual angle of 135 degrees in the second quadrant, or which is 3 pi over 4. Again, your theta must be written as, so this is 3 pi over 4. Okay, so that's basically it. And now it's also asking us to give us, so let's first graph this. So its r is rad 3 over 2. Now you'll be like, how do I plot that? First of all, 3 pi over 4 is here, and rad 32 is approximately 5 point something, because think about it, rad 25 is, or square root of 25 is 5, square root of 36 is 6. So this rad 32 is a number between 5 and 6. So I'm going to go out 1, 2, 3, 4, 5, and 6. So like right in between. So that is where my point is. Does that make sense? Now it's asking us for two more representations. So 3 pi over 4 was when I went in the counterclockwise direction. So I can rewrite the same r. I can use the same r. I'm going to use a different color. So it would be what? Rad 32, comma, if I go in clockwise direction, what would be that angle? That would be 5 pi over 4. Or if it's 135 degrees, the other angle would be 225, negative 5 pi over 4. Right? We're going in clockwise direction. So that's one representation. I need another one if I go on the opposite side. So if I go on the opposite side, I'll be right here. And the angle would be 7 pi over 4. So I can do negative rad 32 comma 7 pi over 4. If I still use, I'm going to give you another third one. If I have negative rad 32 comma, if I go in clockwise direction for 7 pi over 4, it'll be just negative pi over 4, right? We just added 180 degrees to these numbers. So those were the other two. I gave you 3 representations. So now let's talk about the lesson, converting polar and rectangular equations. So far we have these formulas. I'm going to write them out. X equals r cosine theta, y equals r sine theta. This is used when I want to convert my polar coordinates to rectangular. Then when I want to do the other way around, my rectangular to polar, I use r equals square root of x squared plus y squared, and theta is what? Tan inverse of y over x, right? So these are the 4 formulas that we have been using so far. So now using these, I'm going to be converting these equations. So the example 1 is telling us to convert rectangular equations into polar form. So in the rectangular to polar are pretty straightforward. Polar to rectangular are a little challenging. So what do we do here? So I'm going to substitute x with what? R cosine theta. I don't want any x and y in it. Basically, that's what you should keep the goal. Plus 2 times r sine theta equals 4. Right? I can factor out the r from both of them, and I can write it as cosine theta plus 2 sine theta equals 4. Just factor out the r and write the remaining of the equation simplified. Okay? Part B. So first let's simplify this. This would be x squared plus y squared minus 4y plus 4 equals 4. 4. Look at your 4s. They cancel out. If I move the 4 over, either way, it cancels out. Okay, now do the substitutions. We also know x squared plus y squared is what? R squared minus y is what? R sine theta, right? That's what we did. Equals 0. Factor out your r. What are you left with? R minus 4 sine theta equals 0. And that's your equation. Okay. Now, changing from a polar equation to a rectangular equation, to convert a polar equation to a rectangular form requires us to use various relationships between r, x, y, and theta. So again, I'm going to rewrite those rules or formulas that we know about. R squared equals x squared plus y squared. What else do I know? I know x is equal to r cosine theta, y is equal to r sine theta. I don't know if I would need this, but I'm just still going to write it. Theta is what? Tan inverse y over x. Okay. So whenever you want to do this, if you look at these equation, if in A, you want to write it, you want to get rid of r and cosine theta, right? So how do you do that? With these equations, you always start by multiplying with r, because if you look at this formula, it's r squared. So you want to multiply with r so that you end up with r squared. So on the left side, you'll have r squared. On the right side, you'll have negative 5r cosine theta, right? What is r squared? Same thing as r squared is x squared plus y squared equals negative r cosine theta is what? 5x. Set it equal to 0. This is actually, if you were to do completing the square and everything, this is actually equation of a circle. Or, yeah, this would be a circle. Equals 0. Okay? Now the next one, again, the first thing, anytime, this is one of the most important things. From polar to rectangular, start with multiplying by r on both sides. So this would be r squared equals r 2r sine theta plus 3r cosine theta. Because think about it, if I substituted sine theta would be y over r, right? And that would really not help me. because I still will end up with theta or r in my thing. Now, once you know this, you can just substitute with x's and y's. So r squared is what? X squared plus y squared equals 2 times y plus r cosine theta is 3 times x. Move everything over to x squared minus 3x plus y squared minus 2y equal to 0. And that is your equation in rectangular form. So basically they're not that crazy. You just have to know your formulas, and remember, whenever we are converting from polar to rectangular, we need to multiply by r. So that's basically it, guys. Finish up the remaining lesson. Good luck.